Welcome to the short video on classifying real numbers. First, let's begin with our natural numbers. Natural numbers, also known as counting numbers, are numbers that you used your fingers when you were counting when you were little. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way to infinity if you wanted to. Okay? Next, we have what are known as whole numbers. And the only way that these differ is we're going to include 0 into the mix. So it's 0 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to infinity. Okay? After the whole numbers, we then extend our numbers to the integers, okay, which we are still learning this year. Integers are now going to be all of the whole numbers, positive and negative. So now if I think about a number line and I extend it to the left, we now go into the negative numbers. So it's negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the dot, dot, dot shows that it goes to infinity, positive and negative, but it's all whole numbers and their opposites. Okay? After that, we have all the numbers that fall in between all of those. Those are called rational numbers. Now, rational numbers are basically fractional values. So these are the numbers which can be represented as fractions. Okay, so now you might think of decimals. Some decimals can be written as fractions. Most can be written as fractions. Any negative or positive terminating or repeating decimals are included in this set because they can be written as fractions. So for example, if I have negative 6.25, I can write that as a fraction, negative 6 1/4. If I have negative 3.2, I can write that as a fraction as negative 3 1/5. If I think of fractional values such as 1/2, that's a decimal written at 0.5. If I have 1/3, for example, now that can be written as 0.3 with a repeating bar because it's 3, 3, 3, 3, 3 and goes on for infinity. That obviously is written as a fraction and it's a decimal. Okay, 5 3/4, for example, is a rational number. That's 5.75. So any numbers that you can change from a fraction to a decimal or a decimal to a fraction is basically a rational number. Then we have our special numbers, also real numbers, which are called irrational numbers. Irrational numbers, when you think of square roots, are going to be irrational numbers, not perfect square roots. Okay, that's important to know. So square root of 2 is an irrational number. Square root of 10 is an irrational number. Basically, if you had a calculator right now and you punched in square root of 2, you would get a bizarre looking decimal that just keeps going on forever. It cuts off because your calculator screen cuts off, but it goes on forever. So you'd get a decimal, maybe something like this, 2.436729.8. I put dot, dot, dot because it goes on forever. It doesn't stop. You can have a decimal that looks like this, which you might think is a repeating pattern, but it's not. 0.12, 112, 1112, 11112. There's a pattern, but it's not repeating. It doesn't do the same thing each time. So these are all irrational numbers. A little irrational number humor for you. Okay, now let's move on. So let's do a quick review. All right, we've got our natural numbers. All right, these are the numbers you learned as a little kid on your fingers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Etc. Okay, then we've got our whole numbers. So now we include 0 into the mix. Okay, then we've got our integers, which now include negative numbers into the mix. So we've got all of the natural numbers, all of the whole numbers, and now their opposites. So it's going to be integers, the negative whole numbers. Okay, and then we get to rational numbers, which are the fractional numbers in between all of these integers. So for example, 3/8, which is 0.375, or negative 0.4, which is negative 2/5, or 1.25, which is 5/4. Okay? Now we have irrational numbers. Irrational numbers, as I mentioned, are going to be those weird looking ones that are decimals that go on forever and ever and ever and have no sort of repeating pattern. If I look at any square, non-perfect square roots, square root of 5 is not a perfect square, so it's going to be a decimal that goes on forever and ever. Square root of 12, it's a decimal that goes on forever and ever. Now, another one which you may or may not be familiar with is pi. Pi is a decimal that does in fact go on forever and ever without any repeating patterns. Okay? Or if we just want to write a random decimal, there you go. That's an irrational number. So now I want you to try to classify these numbers. Okay? Here's a set of numbers. I want you to write down which set or sets, because they might be multiple, each number belongs to. Okay? So what I want you to do is I want you to pause the video. I want you on your piece of paper write down what you think which set it belongs to. And when you are finished, go ahead and unpause it and let's see if your answers match to my answers. Okay, so pause the video now. Okay, hopefully these are the answers that you got. Okay, negative 1.45 is a rational number. 5.007 is a rational number. Negative 1/6 is a rational number. 7 is a natural whole integer rational number. Square root of 13 is irrational. Square root of 16, I tried to trick you, this is a perfect square. Square root of 16 is actually 4. And 4 belongs to natural, whole, integer, and rational. Negative 5.769 is a rational number. And finally, 8/4, I tried to trick you again. 8/4, if you do the division, is actually 2. And 2 belongs to the natural, whole, integer, and rational number. Okay? I hope that you understand. Darth Vader hopes you understood. And that's it.